So in today's lesson, we're going to be looking at factors, multiples, and prime numbers. A multiple is a number that appears in the multiplication table of any given number. So for example, in the 2 times table, we have 2, 4, 6, 8, 10, and so on and so forth. All of these numbers are multiples of 2. So using these numbers here, which of these do we think are multiples of 4? So pause the video and have a think. Okay, so let's write our 4 times tables out then. So we have 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. So the numbers that are in the example there that are multiples of 4 are 12, 40, 36, and 16. Now have a think about which of these numbers are multiples of 9 and multiples of 3. Now if we start with multiples of 9, let's write our 9 times table out. So 9, 18, 27, 36, 45. I'm not going to go any higher than that because the numbers don't go higher. So in this case, we can see that the multiples of 9 that we have on our picture, we have got 9, we've got an 18, we've got 27, and we've got 36. On our next one then, multiples of 3, so let's do our 3 times table. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, goes a little bit higher, we have 33, 36, 39, and then our numbers don't go any higher on the example. So we've got a 3, we don't have a 6, but we have a 9, we've got a 12, we don't have a 15, but we have an 18, we also have a 21, we don't have 24, but we have 27, we don't have 30 or 33, and we have 36, and we don't have 39. So a multiple is something that is in a times table, and a factor is a number which goes into another number without leaving a remainder. So for example, the number 12. We can make the number 12 in a few ways. We can do 1 times 12, we can do 2 times 6, and we can also do 3 times 4. So the factors of 12 are 1, 2, 3, 4, 6, and 12. So a factor is what can go into it, and a multiple would be its times table, so 12, 24, 36, and so on and so forth. Now we've got a little question here for you to try yourself, which is, what are the factors of the numbers on the slide? So pause the video and figure it out. So when we're finding factors, I think the easiest way to do it is to write the numbers 1 to 10. You don't have to go as far as 10, but I'm going to do that down the side, and then figure out what you have to times by to get your answer. And obviously if you can't do an integer, if you can't do a whole number, then cross it off your list. So we'll start off with 8. Now obviously I know that there's no point going higher than the number 8. I'm going to go as high as 4. So we can do 1 times 8 to give us 8. We can do 2 times 4. We can't do 3 times anything because that won't give us 8. And we can do 4 times 2. We've already got 4 times 2 here, haven't we? Because remember that 4 times 2, 2 times 4 are exactly the same thing. So we don't need to write it twice. So our factors of 8 are 1, 2, 4, and 8. Okay, our next one then we're going to do is 13. So again, I'm going to go 1, 2, 3, 4. I'll probably go down as far as 6 and see if we need to add more after that. So I can do 1 times 13. Can't times anything by 2, or 3, or 4, or 5, or 6. And actually, if I keep going, I'm going to find it's only actually 1 and 13 that I can times to make factors of 13. So the answer to that one is 1 and 13. Okay, next one we're going to look at is 30. So same thing again. I'm going to write these ones down. I'm going to go as far as 7 because I can always rub them out. So I can do 1 times 30. I can do 2 times 15. 3 times 10. Can't times anything by 4. I can do 5 times 6. And obviously I don't need to do 6 times 5 because it's the exact same as 5 times 6. So let me get rid of those ones. So our answer to factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Just to make space, I'm just going to rub out some of this, otherwise I'm going to run out of space. Okay, next one we'll do factors of 18 now then. So same thing that we have been doing, let's write down times tables. So 1, 2, I'll go as far as 7. Again, I might not need them all. So I can do 1 times 18. I can do 2 times 9. 3 times 6. I can't do anything times 4 or 5. And obviously, again, there's no point doing 6 times 3 because I've already got it here. So let me rub these ones out here. So our factors of 18 are 1, 2, 3, 6, 9, and 18. Next one is factors of 24. Go as far as 7, and then as I keep doing, I can always get rid of them or add more. So I can do 1 times 24. I can do 2 times 12. I can do 3 times 8. Can I do 4? I can do 4 times 6. Can't do 5. And obviously, now that we're at 6, we're back to here. So let's rub these bottom ones out. So our factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So there is a lot of factors for 24. Okay, next one we're going to look at is 53. So let's write our multiplication down again. Let's go as far as 6, shall we? So we can do 1 times 53. Can't times anything by 2, or 3, or 4, or 5, or 6. And actually, if I keep going, I'm going to find that similar to the 13, the only factors for 53 are 1 and 53. Okay, next one I'm looking at is going to be 27. Let's go to there for now. So I can do 1 times 27. Can't times anything by 2. I can do 3 times 9. Can't do 4. I can't do 5. Can't do 6. Can I do 7? No, I can't. I can't do 8. And then obviously that's going to bring me back to here. So my factors for 27 are 1, 3, 9, and 27. Okay, 2 more to do. We've got 141. So let's start off with 100. Okay, I can do 1 times 100. I could do 2 times 50. Can't times anything by 3. I could do 4 times 25 and 5 times 20. Can't do 6. I can't do 7. Can I do 8? I can't do 8. Can I do 9? No. I can do 10. I can do 10 times 10. Can I do 11? No. Can't do 12. Can't do 13 or 14 or 15. Can't do 16, 17, 18, 19. Come back to 20, which is already done. So our factors of 100 are 1, 2, 4, 5, 10, 20, 25, 50, and 100. Okay, very last one then is factors of 41. Before is 6. Okay, so I can do 1 times 41. Can't do 2. I can't do 3. Can I do 4? No, because 4 times 10 is 40, so I can't do that. I can't do 5. I can't do 6. And if I keep going along, I'm going to find, similar to some of the other numbers, that the only factors of 41 are 1 and 41. So there's actually a couple of numbers there where we only had 2 factors. And I'm just going to circle them, we'll highlight them so you can see. That was the number 13. That only had 1 and 13. 53 only had 1 and 53. And 41 only had 1 and 41, whereas all of our other numbers had quite a few factors. And that's going to be important for our next slide. So have a go at these questions first, which is finding 6 factors of 24 and 6 multiples of 6. So the first one should be quite easy because we've literally just done it. So we can do 1 times 24, 2 times 12, 3 times 8, 4 times 6 to get 24. So you only have to put 6 of these down. So I'm going to put 1, 2, 3, 4, 6 and 8 are all factors of 24. And multiples of 6, remember multiples is times tables. So 6, 12, 18, 24, 30 and 36. So some of the numbers on that other slide only had 2 factors. It had 1 and itself, and we call that a prime number. So a prime number is a number that has exactly 2 factors. Okay, so the first thing we're going to do is to leave the 2 and cross out all the other numbers, and that's because number 2 will only have 1 times 2, so it's only got 2 factors, so it's a prime number. Whereas if we take the number 4, we could do 1 times 4 or 2 times 2. So it's got 3 factors. Or if we took the number 12, yeah, we'll do 12. We could do 1 times 12, 2 times 6, 3 times 4. So we've got a few factors there. So let's cross out those numbers. And then we're going to look at our 3. So the number 3, you can only have 1 times 3. No other numbers are going to go into that. But if we take the number 9, for example, that's left over, we could do 1 times 9 and 3 times 3. So we have more than 2 factors. Same thing again if we leave the 5 and cross out all the other 5 times tables because we can have more than 1 factor in them. And the same thing with our 7 times tables. What we'll have left is our prime numbers that are less than 100. Apart from the number 1, which is not a prime number because the number 1 can only have itself. It's 1 times 1, which gives it 1, so that's not a factor. So last challenge is just think about which of these numbers are prime numbers.